Good afternoon, everyone. Here I'm present driving scene perception network, which is a real-time joint detection, depth perception, and semantic segmentation network. I'm Liangfu Chen from Hammond International. This is a joint work with University of Virginia. And Hammond is together with Samsung is one of the pioneers in the automotive industry. Talking about autonomous driving, people are really seeing a similar picture as this one. They perceive to detect the objects in the road and along with distance to each object. But however, this is just the advertisement from camera and video processing sensor supplier. And the reality is very crucial for engineers to how to detect and estimate those distance to each object, and estimate the precise lane markers. This is the early development from mobile eye in around 15 years ago. But they estimate lane lines and horizon from the image, and so that they can estimate the distance. The reason is simple. They make a semantic diagram from the image geometry and estimate the horizon from the lane lines. But the reliability is quite low because on the highway the road can be up and down. So this is quite not reliable in reality. The alternative approach is to perceive depth using similar deconvolutional architecture. This is recently development in popular networks, but this is in picture perception, depth perception in pixel size. It is not reasonable to perceive the object level depth. So more recently, there's a work presented just this afternoon. There's a work joint detection and SLAM algorithms so that it can perceive depth and the object level distance. What we are trying to do is to simultaneously detect objects, distance, and the lane lines on the road with efficient algorithms to perceive on the road so that it can run in the embedded system. One of the challenges is to detect the objects on the road, and the capability of estimating the distance precisely and robustly on the road. And we segment the lane lines, as lane lines are not detectable with blind boxes. So we are quite, it is quite challenging. So there are more challenges we have to solve. The architecture we have designed here is to make a branch between two tasks. And in the detection branch, we modify the SSD algorithm with additional depth perception module. And the datasets we use is a cityscape dataset with depth perception and semantic segmentation data. And the training strategy we use to flip those data and block gradients from those images. And the results we are getting are quite good. Here's the result from depth perception. And we can see the relative distance perception is very close. And here's a video showing the demonstration. Okay, thank you.